Okay, we're going to talk about simplifying rationals now. So before we graph rationals, we really want to make sure that they are completely simplified, and we need to make sure we pay attention to our steps while we are simplifying here. Okay, so what's important here is really the concept of the number 1. Okay, now 1 takes many forms. 1 could be 5 divided by 5. It could be x divided by x. It could be x plus 3 divided by x plus 3. They are all equal to 1. Right now, what's important is if we've got 5 divided by 5, we can cross it off because it represents a 1. Same thing, x divided by x could be 1. X plus 3 divided by x plus 3, it's also equal to 1. So there are 1s everywhere, and 1 multiplied by a number is just the number itself. So that's what we're really going to focus on today. Right? So first things first here, we should be pretty solid with simplifying these values. What number divides into 48 and also 36? Okay, you want to be able to simplify this by figuring out what values go into both. Now 12 goes into both, so if I divide this by 12, I'm going to get 4, and if I divide this by 12, I'm going to get 3. So the numeric value here is 4/3. And then if I have x to the 4th on the top, and then x to the 3rd on the bottom, 4 minus 3 is x to the 1st, positive 1st, so that leaves us with an x value on top, and that's a simplified rational. Okay? Next rational expression is what happens if I have 20x divided by 15x to the 3rd. Okay, again, what we're looking at here is what numbers or what values go into 20 and 15. Well, 5 goes into both, so 5 into 20 goes 4 times, 5 into 15 goes 3 times. So I know I've got 4 divided by 3. And now I'm looking at the variables. Remember, x to the 1st here. So I've got 1 minus 3 is negative 2. So I've got x squared on the bottom of our fraction. Or you can also think about, look, if I cross off 1x here, I'm crossing off 1x here, so that leaves me with x squared on the bottom. That's another way to think about it as well, too. Okay? Now our third rational example, our rational expression here, is what happens if we have two trinomials over top of each other? Resist the urge to do that. Okay, so many students want to just cross off those x squareds. You're right, x squared divided by x squared is equal to 1, but that's only if they're by themselves. Okay, this is an entire trinomial divided by an entire trinomial. So we're going to have to get rid of that using factoring methods. Okay, so first of all, what numbers multiply to 9 and add to 6? Well, we're going to get x plus 3 and x plus 3, because 3 times 3 is 9. We're using our sum product technique. So same thing down here. We've got a sum, we've got a product. What numbers multiply to negative 3 and then add to positive 2? Well, we're going to get x plus 3 and then x minus 1, right? Because 3 times negative 1 is negative 3, and then 3 minus 1 is positive 2, right? So now what we can see here is x plus 3 divided by x plus 3 is really just 1. So we can simplify this rational, cross off those values because they are equal to 1, and then find out, well, what do we have left in the numerator and the denominator? Well, we have an x plus 3 left in the top, and if there's nothing else, if there's only binomial, you drop the parentheses, and then we have an x minus 1 left in the bottom. And again, here be very careful, right? This is as far as we can go. Resist the urge to want to cross off those x's, okay? We can't do that because remember, this is x plus 3 and then x minus 1. These are two different numbers on the top and the bottom, okay? So that's using our sum product techniques. And then sometimes we're going to use dots or GCF. And in this case, here we're looking at both. So what would this be completely simplified? Well, on the top, we have dots. So what numbers, since we have a difference of two squares, what numbers multiply to 64, right? So we're going to get the values of 8 and negative 8. So I've got x plus 8 and then x minus 8. Now in the denominator, we're going to use GCF, right? So the first, if I look at the numbers, we're going to divide out a 3, and then also we are going to divide out an x, right? Because 1x can come out of both of those values, right? So make sure you write the 3 and then the x on the outside, just like we're doing GCF, and determine what is left over. Now 3 divided by 3 is 1, x squared divided by 1x leaves us with an x. 24 divided by 3 is 8, so we've got plus 8, and x divided by x, look at that, that just goes away right there. It's just going to go away, so we're left with that. Okay. Now notice we have a multiplicative relationship. We're multiplying everything here. Notice that on the top and on the bottom there is an x plus 8. So x plus 8 divided by x plus 8 is really just 1. All right. So what do we have left on the top? There's only one binomial, so I'm going to write x minus 8. And what is left on the bottom? We have a 3x. And there you have a completely simplified rational, right? So x minus 8 divided by x divided by 3x. So be careful here, right? You can't substitute, or you can't cross off those x's, right? You can't get rid of this and that, okay? Because this is a binomial. This is a whole number together, and this is 3 times that number. All right, so we've got to be careful with going too far when we're simplifying these rationals. Okay? All right, last and final example, we have GCF on the top, and then we have dots on the bottom. Okay, so I'm going to look at this. How can I simplify this? Well, I could take an x, and then I've got an x minus 3. All right, and then in the bottom, I've got dots. So I've got x plus 3, x minus 3. And then again, the important thing is, where is the 1? Well, 1's right here, x minus 3. Sorry, I shouldn't cross out x minus 3, and then x minus 3 disappear. So what's left on the top? Just an x. And what's left on the bottom? X plus 3. And again, resist the urge to cross those off, okay? You don't want to do that, because the top is the number, and the bottom is the number plus 3. So they're two different things, okay? Keep binomials together. It's kind of very important in this unit, okay? Hopes this helps, okay? Remember the concept of 1, right? We want to find as many of these 1s as we can to simplify our rational.